Thank you. Thank you. I assumed you would correct yourself.
Can I say something?
Thank you. Thank you. Thank you. Thank you. There, I'm waiting on y'all.
I want you to
Thank
answer
you.
the question.
Well, thank y'all for most of y'all who have your hands up. I'm still waiting on a few more. Thank you. Can someone help our friend out over there in group 3? Thank you. All right. So, y'all are making this too complicated. You have not written down the most basic thing to start. What is the first thing you got to do? You got to work with that parent function. Like, write that down and highlight it and bold it or whatever you need to do. Okay? You got to recognize I need to deal with my parent function first and foremost. I told you, if I've said it once, I've said it multiple times. I would write down the fact that I'm going to do my parent function first. I got people looking at me, and then we're going to get to the test, and we're like, Mr. Kinney, I don't know how to do this. Well, I told you. I taught you. Write it down. So what is the parent function?
X squared.
X to the third.
X to the third, thank you. What's the name of that function?
The cubic.
Cubic. Okay.
And you already know you use -2, -1, 0, 1, and 2.
I will point this out. For most of the parent functions, what are the x values that we want to use?
-2, 1, -1, 0, 1, 2.
Does anyone know a parent function we don't want to use those for?
No.
Square root.
Square root. Remember, if I'm going to do a square root, I want to be able to easily take the square root. Okay? So I wouldn't use that for the square root, but for pretty much everything else, those are good x values. At least any of the parent functions I'm going to ask you to work with. Okay? So how am I supposed to get my y's without having to memorize this entire table?
Cube.
You cube it, right?
Yeah.
Like you don't have to make it harder than that. What is -2 cubed?
-8.
-8. -1 cubed.
-1.
0 cubed.
0.
1 cubed.
1.
2 cubed.
8.
It should not take any more time than that. Even talking through, it took me a minute and a half, right? You got to be able to identify the parent function, create that table, and then you should be on a pretty good pace from there. Yes, Omar.
For cube, would that be like always our parent function?
Well, the parent function is the parent function, right? Y equals x cubed. Are you asking, are these the points we want to use?
Yeah.
So remember what I said. Pretty much every parent function, the inputs that we want to use are -2, -1, 0, 1, 2. The only one that's not really true for is the square root. Because I want to take this, I want numbers I can easily take the square root of. Now, I will point this out because there's another detail I want to add. So remember, here's my parent function. I can graph just those points. -2, -8. -1, -1. 0, 0. 1, 1. And 2, 8. Now, is there more to this parent function than just what I have drawn here? Yes. Because what is going to go on the end of this function? Or my graph? The arrows. Indicating it keeps going, right?
Oh.
And I need you to hear me very clearly on this. Anna, and it's not to call it out, but Anna, earlier you had something kind of like this, right? Drawn. And you got that because you graphed it on the calculator, and it looks kind of like that, doesn't it? Does anyone have an idea why I'm not okay with you just kind of getting a general sketch like this, though?
Because you don't know where it points.
They're not the approximate point.
It's not really approximating those points well, and I need you to understand, the points matter because these points are what? They make the equation true, so they are solutions, right? Those points matter. And there's another point, or another detail I want to point out. Notice, is this blue or teal function ever coming back to the left, or is it going to keep going to the right and up? But you see how, like, when I kind of do a general sketch, I might get off and I started coming back to the left like this? That's not true, right? The details matter here, right? So I want you to graph those points and draw your best sketch through those points possible. It takes practice, That's okay.
So how you get the other table, Mr. Kenny?
That's a fantastic question. After we do the parent function, what are we supposed to do next?
I know you're supposed to do.
Transform.
Oh, we gotta identify the transformations, right? Did you identify your transformations?
Horizontal translation to the left. I mean to the right. 4 times.
So horizontal translation, that's supposed to be an L.
To the right
You still
4 times.
So I want to pause here and I do want to ask, say again? We're going to talk about that in a second. So I was going to ask, right? Does anyone want to ask a question or push on a detail from that? Push back on it at all. Huh? It's not 4 times?
The way he's saying he's not like 4 times, you just go hard.
I think what he's saying is you translate right, not like in multiplication, I don't think is what you're saying with the times.
Like just 4
He's saying that
spots.
you're doing it 4 times in a row. Which I do like that push on that language of, we may not want to say times there because it might make us think about multiplication. Okay? But Caitlin's asking the question of, should it be down? Someone besides Anthony or Caitlin, can y'all give us insight to whether we think it's right, left, up, down?
I got
What you got, Omar?
to the right.
Okay, but why? So you're agreeing with Anthony, but why to the right?
Did you say when it's in the parentheses, like always horizontal?
Okay, I want to pause and I want to remind you. I didn't just tell you stuff, y'all explored it. When the transformations were inside of the main operation, which direction did that transformation go?
Left.
Horizontal.
Just horizontally, right? Because it could be to the left, but it could also be to the
Right.
right. And we also need to remember those are just translations. Reflections, right? It's not left versus right, it's just horizontal, right? Dilations is just horizontal. So first off, Caitlin, what do you think about that statement? Since it's inside the cube, it needs to be horizontal. And this is their point, is that this right here, the x minus 4, is inside the cube, so it needs to be horizontal, not vertical.
Yeah, I have horizontal.
Okay, but if it's horizontal, is that going up versus down?
So it is going left and right.
Uh-huh. Remember, horizontal is a left-right direction. Okay, you with that idea?
Yeah.
So, and that's an important point, so I'm glad you asked that question, right? Horizontal is a left versus right idea. And so why is it to the right instead of to the left?
Because it's not
The
negative.
inverse of negative 4.
And so you're implying something, and I want to push on this and remind y'all, every transformation horizontally acts the
Opposite. Inverse.
inverse, right? Opposite works for translations, but it is the inverse, right? So instead of being left 4, right, minus would be to the left, it's actually to the right. And so we want to notice, what are we going to do to the x value?
It's going to, the x value is going to add 4.
Right? Yes, sir.
So basically, if it's inside the parentheses and it's positive 4, you have to make it an inverse, so it would be negative 4.
So it'd be to the left, and you would actually be not adding, but subtracting. It's always the inverse. Does that answer that question? Yes, ma'am.
Still listen. Now, you say horizontal translation down, say 7. Do you take points off if you want to test, but you know you said right 7?
It depends on if you show me left versus right. Yes, you will lose some on that rubric, but y'all got to remember, those aren't points. Those are scores that are tied to your level of understanding. So if you tell me horizontal, but then you start talking about up and down, is there some misunderstanding there? So that'll be reflected on the score. Yeah. But depending on the rest of it is whether you'll be at a 4, 4.5, or 5.
So, Ms. Ken, I got a question.
Hold on, Omar had a question first.
Oh, my bad.
So
Yes, sir.
Would that be like an explanation, like error, like a,
Right there?
no, like what you were just talking about, like?
Yes, that'd be part of the justification or the explanation. The evidence for your claim. Right? Mm-hmm.
Alright, you go ahead.
And I would make the note, right, I would show this coming over to here. Alright? So, what was your question, Anthony?
So how do you get the y?
That's a good question.
We got the x.
So we have our transformations for the x. Anybody have an idea for our y's?
I know that it's a vertical reflection. I mean vertical vertical dilation. I
Oh,
mean.
so I'm right.
Alright, does anyone want to push on in a disagreement, respectfully with Anthony, or ask a question about why he's saying a vertical dilation?
No, because the
Is it?
3/4 is being multiplied to the x.
And it's a positive.
Yeah.
Now be careful, is the 3/4 being multiplied by the x?
No, it's been
It's
multiplied
being
by the x
multiplied.
minus
That's what I'm
4
saying, that's what I'm
cubed.
saying.
Right, so it's outside the main operation, so it is a multiplier, so it is a dilation, right? It's outside, so it is,
A vertical.
Vertical.
I was right about that.
is it supposed to be a reflection as well though?
It ain't no
not
negative.
Ah, only those negatives cause those reflections.
Yeah.
Do not forget that, okay?
That is funny, man.
So what is that vertical dilation by?
4/3. You gotta get the inverse,
Okay.
right? Oh no.
Jenny, do you agree that it'd be by 4/3?
Why would you get the? Oh. My bad.
You're good.
Oh yeah, it is 4/3.
He's super convinced. Do you agree with him, Jenny? Or do you want to push back on that? Not sure. So we need to know this. Iona, do you agree 4/3, or do you think it's supposed to stay as 3/4?
It's supposed to say.
It's supposed to stay the same?
Look at my note.
It's on the outside?
Yeah.
So if it's vertical and it's on the outside, you're saying it stays the same, it's not the inverse? So you're thinking it's by 3/4. Quick thumbs up if you agree that it's 3/4. Thumbs down if you agree that it's 4/3. I'm waiting on everybody to put a thumb up.
Hold on, you said,
Up if you think it's 3/4, agreeing with Iona. Thumbs down if you think it's 4/3, agreeing with Anthony.
Hold up. I got a extra.
What is it? What is that,
Okay, so hold on. All right, so I see most of us with an answer. Say your question again, Jakayla.
Why would you, when have you ever swapped those? Like,
What do you mean by swapped?
when have you ever did like flip this?
The reciprocal.
So you're talking about the reciprocal or the inverse? What is those though?
Inverse.
Yeah.
Of the fraction.
I mean, we have done the inverse.
I know we have, but I'm saying, when have you done it with these type of problems?
We have.
We have.
When?
And I can't say too much more because otherwise I'll give it away.
Hold up, Miss.
Let me ask you this question. When do we use the inverse?
When it's vertical,
When it's horizontal.
I thought we just did the inverse when it was horizontal a second ago.
you do it both.
We just always do the inverse?
No, you just do it on a horizontal.
So I'm going crazy.
Wait, what?
Gerald, are you paying attention? Kylie, I need you paying attention up here. We're having this conversation. I need you all listening. Look.
I'm confused, bro.
I can tell, and this is why I need you to slow down and I need you to think about it. The only transformations that have ever been the inverse were the horizontal.
Okay, so I'm right about it, don't.
The vertical, I need you to remember, I'm going to go back to this equation. What is this equation I'm referring to?
Vertex.
That's vertex.
Vertex of a quadratic. Notice how it's x minus h?
That's the only.
So we needed the opposite there. But you see how it's plus k? Did we ever need the opposite or the inverse there?
No. See, that's-
Vertical has always been the way it appears. Only horizontal has been the inverse. If you did not get that correct here, you might want to write that detail down. Horizontal transformations act the inverse. Vertical transformations act the way they appear. So, vertical dilation by what?
3/4.
3/4. Would I call that a compression or a stretch?
Stretch.
Yeah. Wait,
So remember, a stretch means it gets bigger. Compression means it gets smaller.
would it be a compression?
Compression.
If I multiply by 3/4, it's going to get
Small.
smaller.
Yeah.
That number's between 0 and 1, isn't it?
Yeah.
Oh.
So no, we're going to multiply y by what? 3/4. So multiply that y by 3/4.
Hold on, can you explain how is it a compression again? Real quick.
So think about it this way. If I take 8 and I multiply it by 3/4, put it in your calculator. What's 8 times 3/4?
6.
That's 6. Positive 3/4. So Omar, did that number get bigger or smaller?
Smaller.
I went from 8,
Oh, it got smaller, yeah.
that's a compression. Anytime the number's between 0, anytime the factor is between 0 and 1, it's going to compress because those numbers make numbers smaller.
But would you, like, where you get that 8 from, though?
I made that up in this case. Actually, I didn't fully make it up. Notice we have a y value of 8 right here.
Yeah.
But I'm just using this as an illustration. If I take a number and I multiply it by 3/4, did that number get smaller or bigger? Smaller, so it compressed. Okay?
So what you originally were using before you used 8, you used 4 then?
What?
On my 3.
No, I was just pointing out if we multiply by 3/4, it makes the number smaller. I just created that as an
I thought we
example.
were using x, the x 4.
No. Remember, there's the x. Notice, we gotta be careful. The horizontal affects the x. The vertical affects the y. So now I can make a table.
How do you apply 3/4 on the graph?
Well, I make my table first.
I mean,
Notice, I'm going to do my horizontal translation to the right 4 first, so what's happening to every x?
they're going up 4.
Be careful about that language.
I mean, add 4.
Add 4. Because remember, up kind of implies vertical.
Yeah, my bad.
What's -2 plus 4? -2 plus 4.
I'm sorry, I was yawning.
Wait, it's
2.
-2.
2. -1 plus 4.
3,
0 plus 4.
4.
5,
5. And 6. And instead of making my life hard, I'm just going to do exactly that now, right? I've already taken care of the horizontal. And you might want to make the note, right? Plus 4. So what's happening to each of the y values? Multiplied by?
3/4.
What's -8 times 3/4? -6. What's -1 times 3/4? -3/4. 0 times 3/4. 1 times 3/4. And then 8 times 3/4.
So you gonna always multiply your denominator by your y value?
What? I just took each of these y values, and because this was vertical, I multiplied each y value by 3/4.
Mine don't look good.
Omar, are you good with the fact that it's a vertical dilation by 3/4?
Mm-hmm.
Okay. Because it's vertical, I'm going to multiply the
Y.
y by,
3/4.
so I took this y value, and what did I do to it?
You multiply by 3/4.
Okay, I took this y value, and I multiplied it by 3/4. Took this y value, and I multiplied it by 3/4, which got me 0. What's 1 times 3/4?
3/4.
8 times 3/4. That's it. Yes, ma'am.
But
So in your transform, the whole table gonna be different?
Yes, it's a transform function.
so you got
So
that.
why in the, why on the ones that we did Friday, the X values or the Y values will be the same?
Well, some values can stay the same. It depends on if there's a transformation. If the x value stayed the same, there was no horizontal transformation. If the y value stayed the same, there was no vertical transformation.
Okay.
Right? You got to separate the horizontal from the vertical. That's it.
And in this case, it had both of them.
Right. It had both a horizontal and a vertical. So I had to do something to the x and to the y.
And if it only had a vertical, then it'd just be the
Y.
minus change.
Mhm.
Okay.
Notice I graphed my points from the table, and so I can't just have a general sketch. I got to have somewhat accurate points. I'm going to look for those accurate points, and then for you to draw a sketch through them. Now, I will say this. You don't have to make a table every time. fact, I can do this without a table, and I'll show you how in a second, but I would recommend it. I would do the parent function table, and I would do the transform table after identifying those transformations.
I'm thinking you go to 3, and then you just go up a little bit more. That's what I know.
It's a little bit below 1.
Yeah, that's 9.
So.
Yeah.
So when you trying to find your other table, you use your horizontal translation, and you like, if it's a positive, you add it to your already, the X you got from the first table.
So I would determine if it's left or right. And if it's left, you're going to subtract, and if it's to the right, you're going to add. Okay, the reason I say that is because notice it's x minus 4 there, right? But I needed the additive inverse.
And with your vertical, you just multiply it by your y value.
Now, you got to remember, that's because there's a translation versus a dilation. If it was a horizontal dilation, I would multiply the x.
But basically, he's saying you're not gonna always have to change both of them. Sometimes you can have a horizontal change or a y, like we did on Friday.
Well,
That's basically what I would add.
that's a big part of it, but also I just want to point out this, Omar. Are you good with the fact that this 3/4 is vertical?
Mm-hmm. I know that.
Am I adding or subtracting that 3/4 or multiplying?
You multiply.
So what am I going to do to the y values? I'm going to multiply. Right. It was x minus 4. That's adding / subtracting, right?
Yeah.
So I'm going to add or subtract to the x values.
You're gonna add.
It's just, and I'm going to add because I need the inverse. But I would identify these transformations and then determine my thing, what I'm going to do based on the transformations. Because I know that a translation is adding or subtracting, and I know a dilation is multiplying. Right. So, what are your questions before I continue? Okay?
Hold up.
No.
So, say if like the 3/4 was like a reflection, you'd be multiplying negative 3/4.
Mm-hmm. Good. Great question. Yep.
By y.
Mm-hmm.
Okay.
Mm-hmm. That's exactly right.
Oh, so reflection basically like the inverse of dilation.
Be careful with that because I wouldn't say it's the inverse. When there's a reflection, the opposite is involved. Because notice it goes from positive to negative. So it's like a mixture of things. So one thing I do want to point out is you can do these transformations just off the graph. I would never recommend it. But notice this point right here, translated to the right, how far? 4. And then the y value is multiplied by 0, so it's, or is 0, so 0 times 3/4 is just that number. This y value was translated to the right, how far? 4. But then what's 1 times 3/4? 3/4. So you can do it on the graph that way, it's just harder. This point right here was translated to the right, 1, 2, 3, 4. But then what's 8 times 3/4? 6. So it became that 6. So you can do it off the graph, it's just harder to do it off the graph. I would always recommend the table. Alright.
Miss Ken, I got a question for
I
you
don't have an answer.
before we start. Why you want to go into the field?
Because I need you to work on that, on your own.
Alright,
It'll be due Friday.
is there 2x being multiplied?
Yes.
So it's
There's
gonna
no addition, no subtraction, no division symbol, right?
be, yeah.
So it has to be multiplication.
So it's going to be a vertical, not a vertical, but a horizontal dilation. Can you have a horizontal dilation?
I mean, it's multiplying, right?
But we ain't never
This-
encountered with a horizontal dilation.
Yes, we have. Yes, we have. You definitely have.
No way.
Way.
So, okay, I know it's vertical reflection.
Okay, so where do you see a vertical reflection?
That -1 on the outside.
Okay, so vertical reflection.
Alright. You got horizontal translation to the left, 3.
That's horizontal translation.
I mean vertical translation to the left, 3.
Y'all agree? Vertical translation left 3?
Yeah,
Yes,
it's
sir.
on the outside.
And then
You'll need to
horizontal
re-examine that statement.
Up 3.
up
if
3,
it's-
up 3,
If
up
it's
3.
vertical, can it be to the left?
No,
No.
No.
Up.
Remember, if it's vertical, it's gotta be up or down. So why is it up in, because you said left.
It's
Oh, it's
up 3 'cause
outside of
positive.
it's positive, and don't forget, vertical acts the way it appears, right?
Yeah.
But as soon as you say vertical, you gotta think up versus down, and because it's vertical, it just goes the way it appears.
And then horizontal, dilation.
By what?
2.
Anybody want to push back on that or ask a question about that?
Nope.
No, it's horizontal dilation.
Okay, and we all agree it's times by 2?
Yeah,
No.
look at this map.
Oh, yeah, is it a horizontal dilation to the left too?
Well, remember, left versus right would be a translation.
So,
It's just.
When you add or subtract,
oh, it's
it's
just multiplying, so yeah,
it's multiplying.
it's just 2, yeah.
Okay, but I do want to pause. I want to remind you, horizontal transformations act the inverse. We got to remember, horizontal act the inverse.
Is it one
What's
divided
the-
by 2?
Multiplicative inverse of times 2 is times
Got
is
divided
one.
by two.
half, right?
And I remember that because she said you only do that with square root, right?
Mhm.
Well, not with the square root, but it was something she said that, like how this one is,
Yeah.
you only have to change it if you look like that, but if you look like this, you don't have to change
No,
it.
you have to change that as well. What's the multiplicative
I mean, would it
inverse of
just
1
be
half?
2?
It would just be the 2.
Yeah, but this one.
So-
would be the-
Anthony, I do want to direct your attention to the very first page of this packet. You definitely had horizontal dilations there. So you might want to go back and study that a little bit. But it is important to recognize, and so again, a lot of this information is from the last question, but you have to go through and identify each of these details, and then you can apply this information to the parent function table. What are your questions about these transformations before we continue?
You said on the front page,
Yeah?
The second one from the last one.
I would
And
point
the
out the
second one.
third and the fifth all have horizontal dilations. No, second and fifth have horizontal dilations.
Yeah, they like-
yeah, I was talking about like when you had the graph of horizontal dilation.
But if you create the points in a table, you just graph the points in the table, dude. Like, can you do the parent function for y equals the square root of x?
Huh?
Can you create the parent function table for y equals the square root of x?
Yes.
Y square root of 8.
Isn't that the parent function, Anthony?
Oh, yeah, you can too. Huh?
That's square root.
Yeah, the
Bro,
ones
you're
that
taking
you
the square root.
The,
You can take the square root of 2 too, okay?
Put it in the calculator.
if you use this one.
Oh, dang, I'm retarded.
I wouldn't go that far. By any stretch of the imagination, you just need to slow down. You're trying to rush things instead of think through things.
Man, it's
Well, remember, a square root, you want to take the square root, right? Can you easily take the square root of 0? Can you easily take the square root of 1? Can you easily take the square root of 4? So, I wouldn't use other numbers in between because you can't take the square root of those easily. But what if I were to go further, what's the next x value I could easily take the square root of?
25.
Right. Square root of 25 is 5.
I thought you
Oh,
said you
this
look
one
at
is-
it left to right.
On this one is the.
Isn't 0 the leftmost value?
Oh,
Then
you can
1,
change this
and then
negative.
4, and then 9. Notice we're not doing negatives, because we talked about that
Yeah.
last week or 2 weeks ago.
It's imaginary.
The square root of those negatives is imaginary.
Do the x values change on this?
You'll tell me, do we have anything horizontal?
Yeah.
So then, yes.
And then, well, so both of them.
So you can't even do that one. You can't even do 2 times 0. You got a horizontal dilation.
Yes, you can. Well, first off, it's not 2 times 0, it's times what?
1 over 2.
1 half. But can you do 0 times 1 half?
Yeah, it's 1/2.
No, dude. Use a calculator.
0 times 1/2
Uh-huh.
is 0.
Thank you.
Oh, so for this one, we'll just be multiplying the x's and our y's gonna stay the same?
I would agree that we are multiplying the x's by what?
1/2.
Is nothing happening to my y's though?
It is something because you got a vertical
Remember we got a vertical reflection,
Yeah.
and then it's being vertically
translate.
translated.
So we was multiplying those by 3. No, add them by 3.
Well, first you're going to reflect, and then add. I say it in that order because, oh my gosh, did not plan on going over this one. So, remember, times 1/2 for the x, but when I look at the y, I'm going to reflect that 0. What's 0 times a negative?
0.
0. And then we're going to translate up 3, so I'm going to, if it's going up, I'm going to
Oh, plus 3.
add 3. So 0 plus 3 is 3. But what's the opposite of 1? Remember, I'm multiplying by a negative. Negative 1. And then I'm going to go up 3, so it's going to be 2.
So it's like I'm making my y values negative.
Well,
When
that's
I
what a
add.
reflection does. It makes the y values negative.
So why didn't it make them negative when I was doing like when I first put them up there? Like
This is the parent function. This is the transformed function.
I know, but you said like since it's a reflection, it's gonna be negative. Instead of-
Right. And so we did 1 times negative 1. That was the reflection, right? And then what did we do after we reflected? We added 3. Technically.
Well, let me write that note.
0, negative 3.
Okay? So you're reflecting, multiplying by negative 1, then you are adding 3.
So how you do 1/2 negative 4? What's 1/2? Where is 1/2 negative 4?
What? Where do you get 1/2 negative 4 from?
You get 1/2. 1
Anthony.
times 1/2.
Anthony.
It's just 1/2.
I reflected first,
Make your y value.
then I added 3, so it was 2. Not negative 4. You added 3, then you reflected.
So you gotta reflect, then add 3.
Correct.
That's
We
so it's
won't-
gonna be positive.
Yes, yes.
But what's 1 times negative 1? Negative 1, that's the reflection. Then you add 3. I will not make you do both a reflection and a translation at the same time, because it does get a little bit trickier on understanding checks, but that's what's happening.
So 1.
But Anthony is correct on the x value here, but Anthony, you see how here's 0 and here's 1? Isn't 1/2 just kind of in the middle?
Hold up, I can't see.
Yeah.
Okay, so then 1/2 is 2. It's a point.
Oh.
We have 0.03, you need the rest of those points. By the way, after you do all this by hand and you justify, can you check yourself on a calculator? Yes. Don't just jump to the calculator, but check yourself with calculators. If you want to bring in a laptop or anything like that, I have free copies of the software for the TI Inspires. You can also just go to desmos.com. Yes, Gerald.
So basically, it'll be 4 times 2 plus negative 3.
4 times 2? What?
What about the next one down, that's the one.
But you gotta remember, if it's horizontal, it acts the inverse. So it's not by 2, it's by 1/2.
I gotta do this now.
But Mr. Kenny,
You're staring at me. Just use a calculator, it's 4 times 1/2.
but if you do 4 times negative 1,
Why are you doing 4 times negative 1, Anthony?
the reflection.
But Anthony, the 4, is that my x or my y?
Watch how I do this. I got the keys.
Bruh. So you do 2 times negative 4.
No,
2 times negative 1.
thank you. Look, you've got to separate your horizontal from your vertical. I cannot emphasize this enough, y'all. If it's horizontal, what's it going to affect?
X.
X. If it's vertical, what's it going to affect? The y. So, if you want, this might be a good idea for you to show your transformations off to the side, right? So we identified horizontal by 1/2 over there. So maybe you want to make a note to yourself, x times 1/2 here. And so 1 times 1/2. That's how I get this half, right?
Mhm,
Yes?
mhm.
Then 4 times 1/2. That gives me what?
Something.
You got calculators, fam. Thank you. 2. Then 9 times 1/2.
9/2.
Not 9/2. 9 divided by 2 are 9/2. So, notice, Anthony, I've separated my horizontal because only horizontal affect the x. Right? Vertically, what are we doing vertically? So, multiply by -1, then add 3. That's what's happening vertically. So what is 2 times -1?
2, -2.
And then you add 3.
1.
Then we take 3 times -3, or 3 times -1
-3.
plus 3.
0.
That's it.
Yeah, that's gonna be simple now.
Well, it's just hard. It's because we're reflecting and we dividing. We're reflecting and we dilating at the same time.
But you're not. Like, I know what you're saying, but that's why you've got to separate the vertical from the horizontal. Because horizontally I'm dilating. But that's the only thing I'm doing horizontally. Right?
Yeah.
So basically, it's like we just plug in a -1.
Well, you're reflecting, so you multiply by a -1, then you add your 3.
I get it.
So
what?
the 8 will be -5.
The 8?
Yeah. 'Cause you know you.
Oh, you're talking about the x value 8.
Yeah.
I was like, there's no 8 up here. You're talking about, you did 16 times 1/2 is 8.
Yeah. Then you do 8 times -1, then plus 3.
Why are you doing 8 times -1, bud? That 8 is an x, right? Yes or no?
Yeah. That's how you trying to get the y.
No.
No, you just.
The way I got the y was starting with a y value.
Oh.
4, that's what's being reflected,
Times -4.
and then that's being translated up 3.
-1. Oh.
I need you to understand, and I need you to write this note to yourself right here, right now. So 8, -1. Horizontal transformations affect which variable?
X.
Affect x. Vertical transformations do what?
Affect the Y.
Thank you. They are completely separate. Do not mix your horizontal and your vertical transformations. Do not mix your x values.
So they really don't have nothing to do with each other when you like transforming it, except when they only correspond with each other when you plot the points.
They do in a way, but it is much easier to just do your horizontal and just do your vertical. Now, what you can do is, if I substitute an 8 into that function up there, anybody guess what I would get out?
A -1.
-1. Which I think is what Anthony's trying to do, is he's trying to do inputs and outputs. But once you transform your x, your horizontal, then you need to just transform your y with the vertical transformations. You can check by substituting it in. For example, if I were to substitute that negative in, or that 8 in, f of 8 equals -square root of 2 times 8 plus 3. What's 2 times 8? Wait, you see how that's this 16 that we originally started with? What's the square root of 16? I think I heard someone say it. What? 4. But notice how that gives me a -4? Isn't that the opposite of this 4 right here? Okay, so there's the reflection, and then after the reflection we add 3, which is going to give me -1. That's it.
I probably wouldn't do it like that.
I wouldn't either. You guys separate your horizontal versus your vertical transformations. We will work on the other 2 sheets that I gave you at the beginning of class. It says transformation functions practice 2 and 3 for about an hour tomorrow, and then we will take an understanding check on these transformations where you have to, when you're given an equation, you have to identify the transformations and you have to create a graph. Tomorrow we're also going to practice going from tables and graphs to creating an equation, and that will be on there as well since we'll spend the whole day on it. Yes, ma'am. As a quick reminder, here is your closing material, your daily practice assignment. The graphic organizer every term through horizontal versus vertical transformations is due tomorrow. The transformed functions practice 1 through 3 is due Thursday, March 3rd. I'll make that Friday, March 4th, because we are behind.
Hey, Mr. Kenny.
No. Well, 1 second.
When we do our test, it's
March.
It's gonna be
Hold on. Friday, March 4th. We will have an understanding check tomorrow at the end of class. And we're going to continue working with this. What I have there for Tuesday will be moved back a day. Omar, what's your question?
When we do our test, it's gonna be like what we doing.
What test?
On this.
Yes. That'll be, this is only the first half of the unit though. Yes, ma'am. Huh? So these 3 were due 1. But you should not have this done yet, because we haven't done anything by non-constant values. And slow down. You're not separating the horizontal versus the vertical.
I know that, Mr. Kenny, it's just, I don't know.
You're not slowing down. If it's inside the main operation, is it horizontal or vertical?
Huh?
If it's inside the main operation, is it horizontal? Okay. Is that going to affect the y values at all? So you just affect the x values with those transformations. If it's outside the main operation, horizontal or vertical?
Vertical.
And so it only affects which values?
Y.
So that's it. Only transform the y values by vertical transformations.
Yeah, but I was just, because I was trying to reflect, and then I was trying to,
But you were mixing your x and your y, bud. Right?
man.
Be quick.
You can't never miss a day. You can't never miss a day. You can't never miss a day, Mr. Kenny.
Me?
Yeah.
I've literally missed 2 days already this semester. That's more than I usually miss.
I think you should miss like 5, 10 more.
Unfortunately for y'all, when I do miss, you'll have my intern teaching. So it's not like I'll really be missing a day.
Now what I'm gonna do, give you, okay.
Put me up. For real.
tomorrow at 10:45. Come at 10:45, you already signed up? Huh? You signed up already? 10:45 was the. It's right here. When we leave this place, I'll show you. Sign up sheet. I'll show you when we leave exactly. It's like right here.
How you doing, buddy?
Oh, we want that. Oh, okay. How are you?
Good. Good morning. Good morning. Okay. Good morning, Chloe. Huh? Where's today?
Show me.
You are really good.
How does that feel scared? I was just making an astute observation based on she's not here yet. I knew not.
Good morning.
You can tell I'm in a good mood, man. I'm being smart ass. I just think just so I can have enough energy to be able to hold this I can't really focus. I just, my body will not allow me to. I'm not even joking.
So you just mindlessly put two answers down?
It's already gone.
If you're claiming it's quadratic, why are you claiming that's quadratic? What do you see in your notes that's telling you that's quadratic?
Oh.
You need to look at those numbers back. Look at those numbers again.